Okay, with the sticks, we just discovered 2 ways to prove triangles congruent without having all 6 parts congruent. One of those ways is by using the 3 congruent sides of a triangle. There are 4 ways that we're going to get over the next 2 days to prove that triangles are congruent. So really tiny if you're proving triangles congruent. One of those ways is called the side-side congruence postulate. We're going to fill in the blanks here with symbols to represent the theorem or postulate. If 3 sides of one triangle, fill in with me, are congruent to 3 sides of another triangle, then the triangles are congruent. That takes not 6 parts, 3 angles, 3 sides, but 3 parts to determine if the triangles are congruent. Next to this, I also want to put a picture to show 2 triangles. So y'all each created 1 triangle, but then there were 4 triangles to compare. So we're trying to show congruence between at least 2 triangles. And I want you to show your tick marks, 1 side, 2 sides, 3 sides. And to know that these triangles, whether we know angles or not, are congruent, we can just use the 3 sides. So side, side, side congruence. Okay. The other one we just determined was that if you have an angle in between 2 sides, so we did it as a side, then an angle, then a side congruence, which is called SAS, or side, 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 SSS, and side, angle, side, SAS. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles, apostrophe S, are congruent. Okay, so filling in those blanks for me, please. Again, there's one picture here, but that's kind of to go along with the definition. So to prove congruent triangles, you need at least 2 of them. Let's draw another one to look similar to this. And it's telling us that we have 2 congruent sides, not 3, but 2. So that's 2 parts. It takes 3 parts. And remember, we did the green side, the yellow side, and we had to put the angle in between them. So I would have to know that included angle. There's a little definition that goes with that. Included angle, the angle that's in between the 2 given measured sides. So again, as you're looking at those triangles, the relationship is a side, then an angle, then a side. And they have the same relationship, side, angle, side. And that proves that triangles are congruent. We did that with the sticks and everybody came out with the same exact triangles. So 2 ways, side, 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 angle, side. Okay, I'm going to draw a little picture here. You don't have to draw this one, but I just want to ask, if I had these markings in these 2 triangles, would that be enough to know that the triangle on the left and the triangle on the right are congruent?
Uh-huh.
I have 1 set of sides and I have 1 angle. Is it going to be side, side, side congruent triangles? No, I don't have enough markings. Is it going to be side, angle, side congruent triangles? So I see you shaking your head yes, but there's only 1 side. What do we know about this side in both triangles? It is the same thing. So even though there's not a mark there, if I separated those triangles, this length is the same in this side as it is this side. So yes, these are side, angle, side congruent triangles, just because that side length is the same there. All right. Here's another example. Let's do like a bow tie. I'm just going to draw and put some markings on here. If I have this side congruent to this side and this side congruent to this side, is that enough information to know that these triangles are congruent?
No.
Wait.
So I would need 3 sides, which I don't have, or I would need side, angle, side. Do I not have an angle?
But
No.
wouldn't those angles be
Yes, you
congruent
do.
because they're vertical?
So even though the mark's not there, I still know, yes, vertical angles are congruent. So these are side, angle, side congruent triangles. So the things we've learned in the past, we want to keep up with those too, so that we can prove that we have congruent triangles and figures. And that's really the goal of today, is to work with congruent triangles and list the names. Okay, yeah, let me go on to one of the proofs then. We should be able to do both proofs. Okay, first one looks like this. So go to your journal, the one you glued in. The other 2 theorems we'll tackle tomorrow. We're just doing kind of half and half. If you'll notice, we're doing congruent triangles all week long in different ways. We're just adding to it each day. Okay, first of all, these need to be segments with congruent bar. So can you mark those on your practice proof? Skylar, you want to work on this with us now? And this is point T because they both have point T in it. And let's call this R and S and this V and U.
Then what's the other angle?
T, shared, and T vertex. Okay, so we're back to doing some proofs. I want to prove my triangles are congruent. So far, I just have the two ways to prove they're congruent by side, 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 and side angle side. So in the two column proofs, let's remember we haven't done one in a while. On the left side are your statements. On the right side are your reasons. What is the way we start our proof?
Given.
With the given statement. My reason is given, and I'll add the given statement in there. So given that RT is congruent to VT and ST is congruent to UT, once I have the given written, let me mark in the picture what belongs there. So RT, we'll put one tick mark in VT, one tick mark. ST, UT. So if these triangles are congruent, then it's not a reflection. Can y'all tell that from the marks? That it would be a rotation because this would have to move over and match up with that one. Okay. We've already basically talked through this problem. Are these congruent triangles?
Yes.
Yes.
Because what else do we know?
Because they're equal.
So the
What's
other side,
equal?
if the one with one
They're
and
congruent.
all that are equal, then you know that RS and UV are also congruent.
Okay, but we don't know the lengths here are congruent unless we know the angles, a certain angle, because this angle could be wider than this one. But what do we know
Those
about
are-
these angles?
Those are vertical, so they're congruent.
So because they're vertical, we don't know these unless we know these, but we do know these vertical angles are always congruent. So that's the part we have to use in our proof. And we're going to state the two angles, angle RTS congruent to angle VTU. Because they are vertical angles. Remember, you have to give your reasons for everything. Angles congruent. Okay. Now I have 3 sets of markings on my picture. I have 1, 2, 3 sets of things listed in my statement side. I have enough information to prove the triangle's congruent by what? Which one of those two ways?
Side angle side.
By side, angle, side, postulate. I know that triangle RST is congruent to triangle VUT. Okay. And in the statements, you must have your parts that's necessary to show that you've proven that. So we do. We have our 1, 2, 3 different things that were marked up there. Okay, proof 1, how's that? We feel okay there? Okay, let's go to proof 2. Should it look like this? Does y'all have the word midpoint in it?
Yes,
Just
ma'am.
want to make sure I'm on the right one. Okay, on the picture we need labels. C is the midpoint of BD, so that means this is C, this is B, and D. That makes this point A. So label your picture with me. This should be a congruent symbol and a congruent symbol. One of these days I will find that symbol in my computer to use it, but I have not been able to find it in my little insert menu.
Wait, what if you, on the line
Go to
above
the
it,
internet
you
and
do-
look up congruent symbol and then copy and paste it into there.
That's what I
What if you just have an extra line? You place like the underscore, and then you hit enter, and you place the letters under that.
So it's a lot of work.
Okay, we'll figure something out. Meanwhile, I'm using the same PowerPoint I have for years, so I haven't gone back and replaced those. On the left side, congruence. On the right, on statements, and right side, reasons. My first thing, Tyson, I did it too. Tyson that I put into my proof is
Given.
Good job, Tyler.
so. Okay, so as far as proving my triangles are congruent, I only have one thing right now. Plus, I need to mark it on my picture. So AB congruent to AD, one piece. It takes three. I either need side, 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 or side, angle, side. Okay. So that means I have some work to do. So let's think back about the word midpoint. They gave us midpoint. So what is a midpoint?
It's the intersection in the very middle.
In the very middle. So if C is in the middle of B and D, what does that mean about the two parts on either side?
They're congruent.
They are congruent. Do you remember why? We have to have a why.
Is it the
Midpoint.
side congruence?
That comes only for triangles.
It's for the midpoint.
It's because when you see it's a midpoint, and it's called the midpoint theorem.
Congruent postulate.
Oh, I thought there was another word in there.
Plus.
Just midpoint theorem tells us BC is congruent to CD, so that's what we need to write. BC congruent to CD. Because of the word midpoint, we use the midpoint.
And then side, because the middle one, you can separate it.
Okay, so yes, we're getting there, but still we only have two parts listed, so we need to list a third part. So what is the third part?
AC.
Okay, so everybody with me? We've got triangle on the left, triangle on the right. Triangle on the left, the last segment's AC. Triangle on the right, the last segment is also AC. There was a property that lets us say something equals itself.
Syllogism.
The reflexive.
It is the reflexive property, bringing back some things that we haven't seen in a while. Reflexive. So reflexive lets us state all three. Now we have one side, we have two sides, we have that side that's shared that's the same. They are all listed in our proof. So which method can we prove triangles congruent? Side, 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 or side, angle, side?
Side, side, side.
Side, side, side. So our reason, and the only time you ever use the side, angle, side, and side, side, side is whenever your statement is you're proving your triangle. So triangle, ABC, congruent to triangle ABC. Okay, so going through our proof again, you had a side, you found another side because of the midpoint theorem, you found another side because of the reflexive property. You've got all three sets of information for side, 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 congruent triangles. Okay?
Yes.
All right, one last thing. I want to make sure that you guys are aware when we name these triangles, I should have done this on the other proof. When we name them, you've got to make sure the letters are corresponding and matching. So angle A does correspond in this triangle with angle A. And since they named ABC, you must name it triangle ADC. ACD would not work because then C and B are not corresponding angles. So you have to find those matching parts. All right. Okay, well, that's all of our notes for today. So let's get the assignment.